Good evening, everyone. This is our 14th talk in the series, and we have a slightly different flavored talk today. So, Atul Bhat, who's a PhD research scholar at Manipal Center for Natural Sciences, has a talk for you titled Exploring Observational Astronomy Activities and Resources for Astronomy Enthusiasts. So, today the main focus will be on setting up and running your own amateur astronomy club. So Atul has a master's from Jain University and is currently involved as a researcher in solar physics. But he has extensive experience as an amateur astronomer while he was at ODP Purna Pragya College, where he was the coordinator of the Purna Pragya Astronomy uh, Amateur Astronomers Club for quite some time. So students, feel free to put forward all your queries regarding this during our interaction session. Uh, okay, so let's start. Over to you.
Okay, sure. Let me just share the slides.
Yeah,
I hope my audio is clear and there's no problem.
yeah, it is. It is clear.
Okay. Yep. Okay, great. Thanks. Good evening, everyone. Uh, Thanks to the organizers for this opportunity. Uh, I met Himanshu less than a year ago, and we were discussing a lot about my club's activities. Didn't know that I would have to bring it to this region this way. But yeah, he was discussing with me about how of course, it's not just limited to that region, but throughout the country, from my experience and others, I've realized that whenever you ask someone what is your favorite topic, everybody says it's astronomy. And some colleges have astronomy clubs that are really active. Some colleges have the privilege of having an institute nearby which can teach them astrophysics. And some colleges need some guidance. So keeping all this in mind, I've created a very simple presentation, and this will basically cover about uh, the very basics of observational astronomy. In fact, that's why we call it amateur astronomy, because when we come to astronomy, not everyone ends up as an astrophysicist, not everyone likes astrophysics, but everybody likes the stars. So whenever we talk about the night sky, we talk about the beauty of astronomy and the thoughts that we get pondered about and all that. So, keeping those things in mind, we may not pursue astronomy as a career. We may not pursue astronomy as a full time thing, but amateur astronomy is a better word for it because we all love astronomy and we would love to do something. And of course, it teaches a lot of things to us. So I can go on for hours and hours about it, but I've got the very small basic topics on what activities can you do at your respective institutions, how you can implement these things for your education level or even lower or higher education levels, or maybe even to public. So with that, let me just give you a brief introduction about Himanshu mentioned that about my previous institution where I worked. I worked at a college called Purna Prajna College. The spelling was here at the bottom. So there we had an astronomy club called the Purna Prajna Amateur Astronomers Club. We like to call it PAC. So we were a pack of students and me, which basically conducted astronomy activities. The club went on for more than 30 years, starting in 1986, and I took over in 2019. And being a little technically gifted, I could take the club activities from beyond just this, what you see in these images. So naturally, when you talk about an astronomy club, what we see in most schools and colleges is they have a telescope. And fortunately or unfortunately, many of them know how to use a telescope. And those of you who can use it, utilize it very well, do conduct programs like this. So you can have skywatch programs, you can look at the stars, you can look at the sun, and so on and so forth. But there is a lot more of things that you can do beyond just looking through a telescope. So that's what I want to really emphasize on. And how to view through a telescope, all of you can find out. You can just Google it, get a telescope. I'll talk about a few of them later on. So you can get a rough idea of what are the different spectrum of activities that you can do. So moving on, uh, every one of us likes astronomy. So when we talk about the beauty of astronomy, I'm sure everyone in this meeting right now can pitch in and tell us why you like astronomy. Uh, Looking at the stars is very beautiful, and knowing certain facts from school, like the fact that some of these stars are 1,000 million times bigger than our sun. Some of these stars are the light from those stars travel to us and reach us only after 60 years. So it kind of gives us a depth or a perspective of how big the universe is. So these are the things that interest us. But what we do not ask is each of these dots, is that only astronomy? Can you do something else beyond just looking at these dots and pondering about these questions? For example, you look at the night sky, the most brightest thing that you can see on most days is the moon. And we know when we draw the moon, most of us draw the crescent part of the moon. From childhood, we are trained to draw the crescent of the moon. But is the moon the only crescent in the night sky that you can see? Or if you look at the moon, is it the same every day? If not, how does it differ? These are all small details in astronomy that each of us can really pay attention to, and it teaches a lot of things. Uh, Maybe due to the lack of time, I didn't really think of covering the applications of astronomy in this, but I would say a few things from whatever we learn later on. But first, let's just focus on what we can see. So, ancient astronomers you will have heard of, like the pyramids. In this image, you can see the pyramid is here somewhere in the right edge. So, we are presuming that this is from Egyptian period, or maybe the Greeks when they were conquering the Egyptian parts of the world. They observed the night sky. In fact, you can see they had big instruments to mark the celestial coordinates. So, telescope was not the thing there. There's no telescope there. People just use their eyes to observe, and that is what we want to focus on. Late Arab periods also, many Arab philosophers and scientists, I would like to call them directly, observed the night sky and contributed largely to this knowledge base that we have. That's why most of the stars today that we know have an, or most of them are actually called by their Arab names. For example, Alcor, Alnef, and many, many, many stars have Arab names because the contribution from the Persian Empire at that period of time is largely influenced astronomy that we know. And us, all of us being from this part of the world, being in India, we also know that Indians have contributed a great deal in astronomy. In fact, I am sure if I ask you to unmute and name this person here, I can get a very clear answer. In fact, we can do that if quickly. Can anyone tell me who is this scientist at this corner, lower left corner? So
Aryabhatta.
very yes. Can you say that again, please?
Aryabhatta.
Yes. So we are shown these images from school, and I'm presuming that we saw the same image from school even when I was in school. These images have shown us that ancient Indian astronomers have been doing and contributing a lot of things to astronomy, the way we know it today. But have we ever asked what have they done? Of course, we can tell the basic things like Aryabhatta told us that when an eclipse will occur, or he could calculate the precise time. But has it's not been taught to us, but it's not also been bothered by us to think how did he do it? There are a very few books that explain the exact method, but we kind of leave it to the people of mathematics or engineering only if they're interested in, and none of us bother to know it. Whereas Aryabhatta was never a PCMB student or PCM student or a physics student or a math student. He didn't choose, I will do only this. He was a polymath. He could do a lot of things. So we also should be able to think in the same line without knowing the complex mathematics that we know today, without knowing the complex theorems that we know today, just by observation. How can we achieve this? So these kind of thoughts are what basically drives an astronomy club, and that is what I would like to push on as well. In fact, India has contributed a great deal to astronomy. Many, many, many rishis and munis and scholars and everyone has contributed a great deal. They have given us the size of the planets. May not be accurate, but they have estimated to a very significant number, right number, about the size of the solar system, the size of the planets, the luminosity, and so many things. So their contributions come without the knowledge of the calculus that we know. Their contribution come without the knowledge or without the facility of a telescope that we all can access today, without the optics that we have, without the softwares that we can access. So these guys, all these ancient scholars, could only observe the night sky and do it. The only difference is today we are distracted a lot. We are busy compared to these people. They had only the night sky to look at. We have a lot of TV channels and YouTube channels and TV shows to follow. But just to give you an idea, astronomy has been at the very core of the Indian civilization. In fact, if you've been to one of these sites, you've got one large site in Delhi, which is the Jantar Mantar. You've also got one in Jaipur and West Bengal, Kolkata, if I'm not wrong. So all these places have been designed to measure some things in astronomy. So astronomy is not simply looking at the night sky and pondering questions. It's about precisely making measurements. So at this point, if you ask me what is astronomy, I would like to put a few points together, calling it as uh, it is basically observing celestial movements. It is looking at the night sky, noticing all the celestial bodies. And of course, you don't need a telescope to do that. And these observations that you do have to be scientific. These observations that you do have to be systematic. So if I observe something today and tomorrow someone else comes and says that, no, that is wrong, I can prove it, then we should be able to change our facts. That's the difference between astrology and astronomy. So, of course, all this is driven by the love for nature and the infinite that we all have. So, keeping these things in mind and not pursuing it as a career, especially for an astronomy club, we all move towards amateur astronomy. And when you go through that, you need to ask these basic questions. Like some of these I've already discussed. Like, how did Aryabhatta calculate the duration between eclipses? It's not really obvious to all of us. We can't do it now, even though we have very powerful scientific calculators. Uh, I can give you the size of the Earth and the Sun if you want, but still, even I myself will not be able to calculate it because I've not been taught. One of the most important laws of physics. In fact, I can say the very first physical law that we know, we study thoroughly today, are the Kepler's laws. The law of the orbits of the motion of the planets around the sun was done without a telescope or a computer. So, how did Kepler deduce the orbits of the planets and know that they are related to their time periods and area covered and so on and so forth? In fact, this is something I always ask my students when I'm teaching an astronomy, introduction to astronomy, that can you really prove that Earth is at the center of the universe or not? I usually take the other way around. I tell them that the Earth is at the center and ask them to prove me wrong. And you'll realize when you look at the different models of the solar system, I've not included the images, but you can always find this. There is something called the Ptolemy's model, and you also have the epicycle model. You have Tycho Brahe's model. There are so many different models that you can actually accept today, imagining the night sky going around the earth and the whole universe is around us, moving around us. So, what took Copernicus, what idea did Copernicus have to negate all of it and show us that Earth is actually not at the center, but it's going around the sun? And how did the ancient navigators who went from continents to continents without the GPS know that north from south? I'm sure all of you know the answer to this. You will think that it's the pole star, but how do you know that that is a pole star? In fact, in the early images I showed you in one of the first slides, there are about hundreds of dots in the night sky on a very clear night. I'm very sure that the northeast part of India has beautiful skies, unlike we unfortunate South Indians here with polluted night skies. So you've got so many different beautiful stars. One of them has to be the pole star. How do you identify that? So it takes a lot of effort and thought to reach there, wherever these great scientists have derived whatever they've told us from. But each one of these ideas starts from very small activities that we can do as part of your astronomy club. And that's what we want to look into. So, an astronomy club, let me diversify the topic here. The astronomy club that you may have in your school or want to form in your school or college or university or any institution need not cater to only the students of that community. You can have an astronomy club as an outreach wing for a college or a university where you go into schools and teach them astronomy. You can have astronomy for public. You can have an astronomy club for students themselves. So based on these different levels of difficulties, I would say, you can conduct so many different activities. And I am going to cover what is mostly relevant to schools, uh, given that I'm assuming all of you are science students. Even if you're not, all of us have studied science till the 10th standard or PU at least. So when you learned these topics in science that is taught to you in school, if I tell you certain activities that I'm going to cover now in these slides, it might look fairly obvious. But then to think of this from the perspective of Galileo did or Aryabhatta did, without the modern knowledge that we have about exact precise size of the planets and so on and so forth, without the ability to just tap your phone screens and get the answer on Google, these activities are very relevant to even adults. And I've had experiences where I've taught these activities to 60-year-olds and 70-year-olds, and they themselves have gone that I've spent my entire life without knowing this. If I knew this, I would be probably more interested in physics or astronomy. So some of these activities are very basic, which I would like to cover here. So, like I said, the first thing that we do in the night sky is observing the moon. And when we talk about observing the moon, we need to really pay attention to the moon because the moon is not as simple as it is. The moon might look very obvious, fairly obvious. It's there every night, but it's not the same shape every night. In fact, if you look at the brightness of the moon, and if you look at it through maybe a very small binocular or a telescope, you'll realize the moon has a lot of dots on top of it, especially visible when it is in this half phase, half quarter moon phase, we call it. When it looks half, but we call it first or the last quarter. Whereas on a full moon, personally, on my personal opinion, is the full moon is very, very, very boring because the full moon looks very bright. It looks amazing in the night sky. When you look at the rising moon, it's beautiful, but then it's just a disk. It's just a white disk with some gray patches on it. Whereas if you look at the moon, we can see the in the image here on the right side. If you look at the moon during the first quarter or the last quarter, the shadows cast by the sun by the shadows cast by the inner rims of these craters that you see here. You see some of these beautiful craters here. So these craters have very tall walls which cast really long shadows on the moon, and you can see these shadows within these craters here. That's beautiful. So you can get to know the details of the moon, and maybe, just maybe, if you can estimate the size of the moon, because all of us have learned topics in geometry like similar triangles. So if I can tell you the distance to the moon, an average distance to the moon, you can actually calculate the angular size, which you can measure actually. There are ways to measure that. So if you can measure the angular size, how much the moon is from here to here, how many degrees will it cover if I have a if I measure it angularly? Or to put it in a simpler way, if this edge of the moon, this edge of the moon, and my eyes are the three vertices of a triangle, then what is the angle covered that subtends this side of the triangle? So if you measure that, then you can actually get the angular size of the moon. And then if I give you the distance to the moon using similar triangles and all these basic geometry things, we can measure the size of the moon. What is the diameter of the moon? And once you know the diameter of the moon, let's say you can capture an image like this, or you can even get one online. Take a graph paper or a transparent sheet and mark the distances like a centimeter scale. And then calculate the uh, radius of these craters. You'll be astonished how big these craters are. Kilometers wide, sometimes thousands of kilometers wide. So this is an activity that none of us think of. We look at the moon, we say it's beautiful. If we have a significant other, we say, "Oh, you look like the moon looks like you. It's very beautiful tonight." And then we just wait for it to rise and set. In fact, many of us, including me till my masters, didn't know that the moon didn't rise in the evening every day. I was so ignorant during that time that it took me a while to realize the moon actually appears with the sun immediately after the new moon. This is a very basic fact that many of you might already know, but I didn't in my masters. So only when we have astronomy clubs that cater to such activities, bring us such activities, we will understand these things. In fact, when you look at the phases of the moon, I have two images here. So one of these is a first quarter moon, which is basically 7 days from new moon, and the another one is actually the third quarter. So for those of you who don't know, the new moon, the first quarter, new moon is the fourth quarter, or it's basically reset. Then we have the first quarter, and then we have the second quarter, which is basically the half moon, which is, I mean, not half moon, half the cycle of the moon, which is a full moon. And then you have the third quarter, and then finally you have the new moon again. So there are four quarters. of which during the first and the third quarter, the moon looks beautiful, like I mentioned. Very significant craters visible along the terminator line, along this shadow region. Now, how many of you can look at this and tell me which is the first quarter and which is the third quarter? Or how many of you can tell me that which among these is the moon after seventh day of new moon and the 21st day of new moon? None of us pay attention. But you will realize if you observe it. I'll tell you an activity that you can do. And also, if you look at the crescent moon or maybe the waxing moon, there are names for these spaces. If you look at these, can you tell me how many days has it been since the last new moon? Or how many days has it been or will it be for the next full moon? So these are all very, very, very basic activities that we have all taken for granted. But a physics student especially can benefit from this. And of course, it's highly beneficial to the public as well. I'll talk about it later. So when you observe the moon, you will have to observe the phases and how it appears in the night sky, along with the craters on it, along with the marks on it. So this image, I'm very sure all of us have seen. This was in our textbooks in the seventh or eighth standard, but we never paid attention to which part of the moon is actually having the darker and brighter region. So you have the new moon, the first quarter, the second quarter, which is the full moon, and the third quarter. So in this image here, the image on the right is actually the first quarter, and image here is a third quarter. And the moon may not appear like this at different regions across the earth. Like in Udupi, this line may be perfectly vertical to me. Whereas if I go to some parts of the world, this line may be horizontal. So the way to identify it is to look at these marks, look at these gray areas. And you'll realize many of us can see the moon as a rabbit. If you look at the moon, you will see these gray areas, gray regions, or the mares we call it, forms a rabbit-like structure with the body of the rabbit here, and this part, which is visible here as the head of the rabbit with two ears. So if you look at the face of the rabbit on the moon, then you're looking at the first quarter, whereas the body of the rabbit, the lower body of the rabbit, is actually the third quarter. None of us know this fact. Most of us do not, at least. I did not till my master's. So one of the activities that I usually do this to school children, but it's very useful for adults as well, is to have a sheet of paper with several circles. I usually ask them to draw it with a 1 rupee or a 2 rupee coin. Draw 30 or 40 or 50 or as much as circles as you can and put a date below each of these circles. And then ask students to scratch, basically shade the region of the moon that they do not see. And try to be as detailed as possible. When you do that, you'll end up drawing the craters of the moon. And once you do this, you will have experiencing the moon, and then you'll never realize, never forget the phases of the moon. And let me tell you, the phases of the moon is a very, very, very important concept to all of us humans, especially Indians, because all our calendars are based on that. Especially today, we follow the Gregorian calendar, which is mostly solar, but I'm very sure due to the cultural heritage of India and the diversity of all the various cultures that we have, majority of the cultures follow the lunar calendar or the lunisolar calendar, which is based on the sun as well as the moon. So when you look at the moon, mostly uh, I would say the Islamic calendar, the Hindu calendar, all of these reset when you have a new moon. Ramzan comes when you have the first sight of the moon, and Hindu calendar starts when you have a new moon. Every month starts in. So calendars are built on this fact. But today, before we are taught about the phases of the moon in seventh or eighth standard, we are basically taught about uh, what do we say? We are basically taught about the number of days, and we are asked to memorize the days and number of days in a month and the name of the week, so on. That we take it for granted. But to realize this is something very beautiful. You can also, not to the human eye, but you can also observe the difference between a full moon during a normal full moon, a super moon, and a micro moon. They are really different. But for this, you'll have to start photographing the moon. And it's not really difficult today. All of us have phones which can photograph the moon. Although the moon may appear like a very small circle, if you know exactly how much you've zoomed in, you can get the circle. Forget about the details on the moon. Just get the circle. I would like to put on a disclaimer. People with Samsung phones, they have mentioned about an AI that can actually uh, do fake stuff on the moon and craters and stuff. So don't get carried away. But any general phone or any devices can actually have these beautiful images of the moon taken, such that you can measure the radiuses. You can basically take two images, put them together on a software like MS Paint for that matter, and draw a line like this. And when you draw a line, you'll realize that the two edges of the moon do not meet along the lines. One is smaller or one is bigger than the other. And that's when you know for sure, as a scientist, as a student of science, that the supermoon is actually larger. Otherwise, we are simply believing people on TV telling us that supermoon is 11% larger and 14% brighter. I would leave it to you to observe how bright the moon is and measure it qualitatively, but you can actually do that. So only when we do these experiments for ourselves, we know that the phases of the moon is actually 30 days, or not really that, it's 29.5 days. So to get that 29.5 number, you would have to do this exercise for several months together without missing many days. And when you do this, I usually tell if you miss a day, leave that circle blank. Do not go to the next, do not scratch it on the previous day itself. So you do it on the first of the month and the second of the month, and I missed it on the third, do the fourth one here itself so that you can estimate the third one. And when you do this for multiple months and you take the average of this, you'll realize it's actually 29.5, not 30 days in a month, in a lunar month. And only when you measure the size of the moon, you realize the supermoon is actually larger, comparatively larger than a normal full moon. So these are the things that we can actually do in an astronomy. Observing the sun is actually the topic of my research. Sun is something very beautiful to observe. But for an amateur astronomy club, sun is basically a circle in the sky, just like the moon. Whereas the moon has a lot of details, the sun has very few details for us to observe. And you can still do a lot of observations, but not on the details of the sun. In fact, rather on the position of the sun. I have used this image here, which is an illustration of the position of the sun across the sky at a place at the same time. So if you have an astronomy club, I would suggest that uh, the activity of the club can be one such activity where you have the uh, let's say an image or a sketch of the surroundings of the school where you look at the sun, surrounding of the college, sorry. When you look at the sun, you can have that as a sketch on a paper. And then every day, with reference to the object at the bottom here, you mark the position of the sun, right? You can even use your hands. If you guys can look at my video feed, then we usually use our fingers to measure how far or how high something is using different hand notation to measure how high the moon is from the horizon, the sun is from the horizon. So using that, you can plot the position of the sun every single day for an entire year at the same time. So given that largely the audience is from northeast part of the country, around 11:30 every morning, the sun will be at the highest point. So you can do that measurement, in which case it will not look like this. And observing it at noon would be slightly difficult because you wouldn't have reference as the sun would appear above you. But if you do it closer to the sunrise or sunset time, like early in the mornings, 9 o'clock, or maybe in the evenings around 4, if you do this with respect to the surrounding regions where you can see the objects and then plot the position of the sun, you'll realize the sun actually makes an 8 figure. And this is one of the reasons how we can prove Copernicus is right, that this Earth is not moving around the sun is not moving around the Earth is moving around the sun. And that is how they do these things. So this is called an NLMA. If you want to make note of this, it's called an NLMA of the sun. And this is something very beautiful. And this happens because we are on an elliptical orbit. So we are going close to the moon and away from the, I keep saying moon again and again. We are going close to the sun and away from the sun. And because of our elliptical orbit, there is a part of the orbit which is closer to the sun compared to the opposite part, which is farther away from the sun. So when we go away and come closer, you'll realize the size of the sun also changes. In this image, they've kind of exaggerated that size here with the smaller dots, but you can still do this by taking a photo. Uh, Today, phones have pro modes. So if you can just dial down the exposure and take a shot, you can actually measure the solar disk as a wide circle rather than excessive light on your phones. Another very important concept in Indian calendar system is the Uttarayana and Dakshinayana. Uh, Sorry that I don't know if there's a local name for you guys there, but we basically call this the movement of the sun. And if you observe the sun, it doesn't rise and set from the same time, same place every day. So this is an activity mostly done from homes because our institutions will not be open during the sunrise or sunset. But if it is, you can actually do this activity, or you can give it as a home task. Where if you observe, if you have a landmark near your place, you take a photograph and do the same thing again. You'll realize in the analemma, it's the same thing. The sun is actually moving from towards the north to the south. And at some point, it's coming to the same place twice. It's going to the north and then to the south, and north and south. The same observations, if you do it at sunrise and sunset, it's easier because you have the horizon where you can mark it. And now you don't really need an image. You can basically draw a line on a A4 size paper and call it that point of view and mark where you see the sun along that point, along that line. And if you do it, you can clearly see that in different months, you will have the sun rising and setting, slowly moving towards the north and the south. And these will tell you exactly the directions you can have. Because today, when we want to measure the directions, we all of us take our phones out. But even before the phones, our parents' generation or our grandfathers, or even during the colonial times, they had the compass. But much, much, much before that, people did have to measure the north and the south and the east and the west. Well, you can get a north from the pole star, but how do you measure the east? We are all told this lie in school that the sun rises from the east and sets in the west. Not really. The sun rises in the eastern part of the sky, but in the month of June, the sun rises from the northeast part of the sky. Whereas, or I can call it the horizon, because if you look at the northeast region in the horizon, you will see the sun rising, and it sets in the northwest. Whereas in the month of December, it rises from the southeast part and sets in the southwest region. So only on the month of September and March, you will have the sun rising and setting in the east and the west respectively. And if you know the date of the equinox, which is usually the 22nd of that month, a day here and there is not really a problem. You will find the true east. So an activity for the club can be to measure the pole star, or you can give them the north direction. You can make it as a night activity to observe the pole star. I'm very sorry that I should have included that as a slide here. But if you look at the pole star, you can use an app to find it, not a problem. You'll realize that over a period of an entire night, all the stars move in the sky except for this one star. So once you know that star, you maybe reserve a part of your institution on the floor, stick a paper or whatever it is, make sure just that the rain doesn't fall on it, and mark the north direction with a scale and a pencil. And then wait till the equinox, or you can do. I have more activities that will tell you to do this later on as well. So on the day of the equinox, if you mark the direction of the sun, you'll realize it's perpendicular to the north. That is only when you can say north and west and east are perpendicular. We have all been taught this in probably second standard or third standard, and we've kind of assumed that it's always like two lines in an X format perpendicular to each other. But no, this is how you need to prove it. Measuring the shadows, this is something that is very important. Here is a small illustration of how the shadows vary across the year. And if you observe closely, you can see that the sun is actually making the eight shape, which I showed you, the NLMA. I'll track along with it if you want. It goes around like this, comes around this point, goes to the side, and then I'm exaggerating the eight shape, but you will see that the sun actually goes in this eight shape. With this, I would like you to ask, look at this, look at the shadow, the way it's formed. You'll realize when the sun is mostly in the south, the shadows are longer compared to when the sun is shining from the north. So you can measure the shadow at noon throughout the year and make so many different observations. And when you make these observations, remember equinox is a very, very, very important day for another activity. So if you look at the equinox, you realize that basically the Earth's equatorial plane. So the plane, or you can imagine this as a uh, basically a cutout of the Earth into equal halves. This is the equator. We have all studied this in school. So this, if it is a really long plane across the whole sky, then we have the celestial equator, which in this image is actually the red shaded region. But if you track really the path of the Earth around the sun, this is not really along the equator because of the Earth's tilt, the equator is not really aligned with the path of the Earth around the sun. In fact, it is actually at an angle of 23.5 degrees. So the celestial equator, which is the equator extended, and the ecliptic, which is the path of the Earth around the sun, are at an angle of 23.5 degrees. And because of this, the sun moves towards the north and the south. You'll realize from this image that when the Earth reaches this point in December, sun is actually below. Sun is always on this plane. The Earth is going around and it reaches here. Sun is actually below the Earth in this level, in this image schematic here. So the sun will shine from the southern sky more than the northern sky. Whereas when the Earth comes to this point here in June, the sun is actually above. It's closer towards the direction of the North Pole. So it shines from the northern sky. And only when it reaches here, from what is this, June to September, and then from December, June to September, and from December to March, the sun will shine directly in a very horizontal way in this image at the equator on the day of the equinox. And that is a very important day. And you will have heard of this very famous experiment. I remember having this in fifth standard. There was this chapter on Eratosthenes, who was a Greek mathematician who measured the circumference of the Earth. The chapter's title, I think, was The Man Who Measured the Earth. So it was Eratosthenes who realized this phenomenon of shadows, measuring the Earth's shadows, and kind of assumed one place was on the equator and another place which he lived in, and he kind of measured the shadows. And what really happens is, on the day of the equinox, the sun is shining directly at the equator, and it kind of, the ray makes an angle of uh, 0 degrees with the normal here. If to speak in purely scientific terms, with the ground here, it will make a proper 90 degree. So with the normal line, which is perpendicular to the surface, the rays make 0 degree at equator. Whereas Earths in India are at a higher latitude. So as we are at a higher latitude, the rays from the sun, which is mostly parallel, don't really come along the object, let's say a pillar or a candle that you can keep. I say candle because it's easier to rub the base of the candle and make it vertical. Or it's better if you have a really long stick or a pole that you can keep perfectly vertical on the ground. And then you'll realize the sun rays don't really fall along the direction of the pole, but it's actually at an inclined angle. And from your space, wherever you're living, this is how it looks like. The sun rays will come this way. And if you do that, you can measure the distance of the shadow and the height of the candle. The longer the candle, the better, because smaller height will actually make it difficult, as the shadow is also smaller. But if you make a really long stick or a pole that you can measure, or even a table for that matter, if you can measure the length of the shadow and the height of the candle, then using just this relation here, you can get this angle A, which is evident from this image here, measures your latitude. Because this angle here, theta, is nothing but this angle here, theta, and this angle is nothing but the latitude. If you are at the equator, this angle is 0. If you are at India, this angle would be, given the center part of India would be around 23.5, and then at the pole, this angle would be 90 degrees. So to measure the latitude, you just have to measure the shadow. And this is a very common activity done by so many people across several science centers and planetariums and so on and so forth. It's a very easy activity, involves a bit of trigonometry. So for those of us who are wondering in each standard, where will I use this tan theta again? For the members of the public who still wonder it, you can actually show them this, and you can actually measure your latitude. And of course, you can verify that value with GPS. But to realize that such experiment and such details are required to be done to measure the latitude of a place and then calibrate all our devices to give these values, you'll realize the real essence of simply writing the word your place. I'll just give a general name of your state, Assam latitude, or any other. For my case, it's Udupi latitude, and Google spits out a few numbers. Now I know what it really means and how difficult it was to measure. So equinox and latitudes is something that is done very commonly, but you need to ask a few things like, why am I stressing on this day of equinox? Why can't I measure this on any other day? I've actually explained this fact. This is because of the angular tilt of the Earth and the planes not matching, which is fine. But then what happens if I measure this on any other day? Will it make a difference? How far apart from equinox can I measure to get the same angle? These are the questions we need to ask as a members of science community or members of astronomy club, and carry out these experiments on multiple days to see get this true answers. So these are the things that you can ask. Measuring the longitude is another activity, but this does not require an equinox. This can be done on any day. In fact, uh, most of us know that the sun is above our head, which we call the zenith, casting the shortest shadows at 12 noon. This is what is taught to us in school. But given the length and breadth of India, you realize that sun really doesn't shine above our head at 12 in the noon every day. Where I come from, in Udupi, which is basically this part of the country here, the sun actually reaches the zenith, which is above my head every day in the afternoon, at around 12:24 p.m., if I'm not wrong. Whereas most of you who may be in this region or this part of the country, or anywhere for that matter, basically towards the right side of this line, you will realize the sun actually reaches above your heads, not at 12, but roughly around 11:30. And why is that? That is because our clocks are actually set for this time, this particular line. So if you stand at this region here, which is basically, I think, Mirzapur, not Mirzapur, some place, Mirzapur only, or Allahabad, very close to that line, which is called the IST line. If you stand at this line along anywhere in this region along this line and measure 12 noon, you'll realize the sun is exactly above your head. And the entire country has set our watches close to this line. And this is the reason why when I visit the eastern part of India, I'm shocked by the fact that the sun rises at around 4:30 or 5:30 in the morning. Whereas where I live, the sun rises only about 7:30 or sometimes 7 in the morning. Whereas you guys have the evenings very early, around, I think I've not really experienced it, so I'm guessing around 5:30 or 6:30, whereas I have the sunset around 7. So all our clocks are fixed to this point. So now we know that the Earth takes 24 hours to complete one rotation. We have 24 hours and 360 degrees. We can calculate how many hours or minutes or seconds for 1 degree. And then based on that, you can calculate how far are you from this latitude. You can get this latitude easily on Google. And then you will measure how far are you from this latitude just by noticing the time difference. You will get about 1 degree for every, I think, 4 minutes. So if you are about 40 minutes away from 12 o'clock, you have the sun above your head, you are about 10 degrees away from this line. And that way you can measure the latitude, longitude at your respective position. And this can be done any day of the year. And yeah, this is how we do it. So you can actually have a gnomon. We call it a gnomon, which is basically a device used to measure the shadows, a white surface where you can measure the shadows, and basically measure the shadows every day. An astronomy club should measure the shadows every day at a specific time. And some days of the year, you should measure the shadow length at every single hour. And only when you do this, you'll realize how the sun moves across the sky. And only when you realize that, you'll realize how the earth moves around the sun. And then you are near Copernicus's idea. And amongst these days, you will realize on one particular day, the sun at noon actually shines from above your head. And at such a point, you can see here in the image animation in the right, when the sun is exactly above your head, the shadows are minimum. If you have a gnomon, then you'll see the shadows are practically zero. And that is what we call as zero shadow days. And these are very important parts, very important events, also celebrated commonly across many science centers in India. If you keep perfectly vertical objects, cylindrical objects, or objects that do not really grow in diameter as you go from the height above, you'll realize on zero shadow day, they cast no shadow. And you can see here clearly in these images, it cannot happen. The shadows cannot be cast because whatever shadow is cast is underneath this object, which you are covering with the object itself. And you can have things made like a stencil. You can see from the previous image here, I've got it made for our club in English as well as Kannada, our regional language here. We can have stencils. Now, a normal stencil, one layer, will allow the light to pass through it any day when the sun is above our heads. But if you have a perfectly aligned, vertically aligned two plates like this with some cutouts, you can do this with cardboard or paper or whatnot. If you do some image out of this, even a circle or a triangle or anything like that, they will cast that image down through sunlight only at the zero shadow moment. And I'm very proud of this image because my student did this. Even I was not able to perfectly align it. So much so that when I did it, the telescope and the name was visible, but the stars were not. You can see it here. The stars were not. Whereas here, I messed up the alignment. But my student got made it possible that you can get this image. And if you really want to be creative, some of you who are into crafts, I have a friend who made this. Apparently, here, I think in the region of Sirsi in Karnataka, the zero shadow day coincided with Henry Poincare's birthday. Henry Poincare was a mathematician, and on his birthday, to pay a tribute, one of my friends living there made a kirigami image, which is basically cutting out pieces of paper to form a stencil-like image, and he did two of these and got a perfect zero shadow image and got a perfect portrait of Henry Poincare. I would say this is the best tribute you can do. So you can be creative in these activities as well. We can, if you have the basics, you can keep a glass like this or a pipe like this and have a zero shadow moment yourself, or get more creative and do these things in your institution. Solstices are the day when you have the longest shadows. So these are also days you can measure. So around summer and winter solstice, you can actually measure these shadows and find out, really prove that sun has reached the most northernmost point in the sky on that day. So these are all scientific investigations that we can do as amateur astronomers. Yeah, so this is how the shadows will be during the summer and winter solstices. So the summer solstice, mostly for us in India, because we are above the equator, we'll have the shortest shadow. Every day at noon, which is when the sun is above our head, we have the shortest shadow of the day. Whereas on the day of summer solstice, we have the shortest shadow of the year, other than the zero. Oh, sorry, we have the zero shadow day, of course. But at noon, we can have this summer solstice and winter solstice. Another very important part of an astronomy club is observing eclipses. They are very beautiful, but care has to be taken. When you talk about viewing eclipses, we usually talk about special eclipse-like goggles, eclipse viewing goggles, which can be bought uh, for an institution. If they have funds, you can buy. Each of these would cost you around 10 rupees or something. But it would be very difficult to manage this because anyone can simply remove the goggles and look at the sun. In fact, you can observe the eclipse using pinholes. And if you have a bigger cardboard box and you have a pinhole that you can put on the top here, you can actually create a pinhole and put a window where you can see the eclipse safely without any issues. There are thousands of beliefs in India that if you put it in reflected water, the eclipse does not affect you. If you put it in water with cow dung, the reflection is safe, the polarization is gone, but none of them are 100% secure. And to try this out would be to lose your eyes. But the pinhole method is 100% secure. You can actually view an eclipse clearly with this. This images and the method for this is given on this website here, timeanddate.com. Another beautiful thing that you can observe from your places is meteor showers. Meteor shower is when chunks of dust left behind by comets are floating in space and the Earth passes through them. And observing them is beautiful. So I have some posters for you guys if you want to look at, which will basically tell you the position of the sky, which stars to observe, a description given, and when and what to observe. I'll just skip this part because meteor showers are quite basic and you can find the information online. But as an astronomy activity, you can also have sunspot observations. If you have a telescope with a sun filter, or if you have a pinhole projector made, then you can actually capture an image of the sun, or basically find the disk, solar disk, and observe spots on it. Observing these spots are beautiful. In fact, for my research, I observe these spots very, very, very closely. Uh, for your knowledge, these spots are bigger than the Earth. Sometimes you can fit like 3, 4, or even 10 Earths inside this one black spot here. That is the size of these spots. But if you observe these spots across several days, every single day, if you observe these spots, you'll realize they will appear to move like they are in this video here. So if you mark these spots on this white disk every day, so you can take your pinhole projector, put a paper in there, draw the circle first, and then mark it one day, mark it the next day, mark it the third day. If you do this for a sufficiently long time, for about a week, you can actually calculate the rotational period of the sun. How long does it take for the sun to complete one rotation on its own axis? And you'll be surprised to know that if you have the sunspots near the equator, the time period that you measure, the days you measure to complete one rotation is not the same as the one in the higher latitudes. That's very fascinating. And that's why sun is the most beautiful object to study in astronomy. But that's more of astrophysics. I'll not proceed with that. But you can do these observations. You can put sunspots on a sheet of paper, measure it every single day systematically at a proper position, and measure the rotational period of the sun. Another way to observe, I told you, is pinhole projector. You'll find multiple projectors, which are basically holes and mirrors put together. But the safest option is this, to have a cardboard box, put a paper in there, mark the circle, and mark the sunspots. For telescopic observations, all of us know it's easier to get information about this online. The night sky is beautiful when you look at it. In fact, you'll find so many beautiful things like the Orion Nebula here is so beautiful that if you Google the images, you'll find beautiful color images. But let me tell you, as an astronomy club uh, conducting activities in the future, people are going to be disappointed. Because when you look at the Orion Nebula through the telescope, this is how it looks. Several times people come to me excited looking at images from NASA like this, telling me to show them planets and nebula. But when I show them this image, they say, "Oh, this is just this boring. Now astronomy is boring." But for them to realize this is actually seen from thousands of light years away is something very fascinating. So it's not simply a job of observing things to telescope. As an astronomy club, we need to explain things to people as well. You can observe planets. Again, the issue with the planets is you will see beautiful images like this online, but when you look at Jupiter through a telescope, you'll only see this one big white dot. But if you're lucky enough, you'll see four and other dots around this, and you'll realize every day these dots are always near this white central dot. And that is when you know that these four guys are going around this giant planet, which is Jupiter. And these are the four Galilean moons observed by Galileo. And that is how Galileo proved that Earth is not really the center, but Sun is the center, and Earth and Jupiter are merely planets. And these are moons, just like our moon going around this. And if Earth was really in the center, these guys shouldn't go around Jupiter, they should go around the Earth. But you can do these observations and measure them. In fact, if you take photos like this every day, in fact, for Jupiter and the moons, you can do this every hour in a night. If when you observe it, you'll realize you can actually calculate the orbital period of these planets as well. How long does it take for this moon, uh, four moons of Jupiter, to complete one orbit around the giant planet? You can look at Saturn and the beautiful rings, but you would require about a telescope about the size of 8 inches. And you can observe Mars, but it won't look like so beautiful like this. It would just look like a dot. And then Venus is something very beautiful because Venus throughout the year has different phases, just like the moon. So observing Venus through a telescope is also something beautiful. So whenever you can find online, whenever the planets are visible in the night sky, rising with the sun, sorry, when the sun sets and these planets rise at the same time, it's the best night to observe these. So you can find out online and do these activities yourselves. Comets, I wouldn't say are really great to look at because they are very rare opportunity to observe one, but fairly, I have seen two or three comets appear recently and they've been bright enough for us to observe. So you can just observe them through binoculars or something like this. And this would not be really relevant now. This was an old slide I had because we will not have another transit until 2034 or something. So by then we'll all not be in any institution anymore. Teaching or learning will be at different parts of life. But a transit is essentially when Mercury or Venus comes in between us and the sun, just like a solar eclipse when the moon comes in between. But these planets are very small, so you can actually measure the sizes also if you want. Occultations are something you can observe, and we have many occultations coming in the future year, 2025. Uh, is when basically the moon passes in front of these objects, and we have the moon covering these objects for a short period of time. So you can see here, Saturn is actually at one spot. The moon is actually moving, not Saturn, but here we have made it change so that the moon is stationary. So as the moon moves closer to Saturn, the Saturn comes closer to the moon and then disappears for a while when it is behind the moon and then reappears again. This is actually more beautiful if it happens on the darker side of the moon, when you have more than a quarter of the moon and not a full moon. Because when the star moves from here, you'll see it disappear, and then it's not going to be visible throughout this path. Throughout this entire path, you will not see the star appear. And here at the border of the moon, suddenly when the star is no more behind the moon, you will look at it and observe like without before the star appears from here, this part of the sky didn't have any dot here, didn't have any star here or a planet here. But out of nowhere from dark, this guy will appear, and it's a beautiful sight to observe. So these are the activities that you can do. And to observe certain things like this, you need telescopes, which I'll quickly cover. Before a telescope, I would suggest always, especially for personal use, do not buy a telescope if you don't know what stars are what. If you're just using an app to identify which star is which, do not buy a telescope. Buy a binocular and learn to spot them. And only then go for a telescope. For institution or personal use, typically 3-inch or 4-inch refractor is good. If you want a manual one, it'll cost you around 15,000 to 25,000, and the higher ends come better. Some of these come with a what do you say, an automated mount or a remote control, which is going to add about 30 to 50,000 more to the telescope cost. You can also buy a reflector telescope, which are better because of the mirrors. And this typically is called a Dobsonian mount, or you can also have an alt-azimuth or equatorial mount also. And these reflectors will allow you to look at the craters on the moon and also planets around and their different moons, and also various star clusters and nebula, the Orion Nebula and so forth. The higher the aperture here, the higher the inch in the telescope name, the better. The best telescopes that you can buy for an astronomy club is a Cassegrain telescope, typically 6 inches. Let me tell you that a 6-inch Cassegrain is better than an 8-inch or a 10-inch reflector. So a Cassegrain telescope is much better, but they are most advanced and the most expensive. And a Cassegrain of such kind would cost easily between 4 to 10 lakhs. So depending on the budget, these telescopes can be bought. And finally, regular activities when you carry outreach programs or go to schools or public and things, the activities you can do is solve crosswords related to astronomy. Now, these are the some of the crosswords I have made for my club when I was there. I have to rebrand them, and I will be releasing them on my website soon. I'll share the link soon. So you can have crosswords where you can use the clues to solve certain astronomy related terms, which will help you learn astronomy because you'll have to search those terms. And this beautiful activity, like all of us have done, connect with the dots. Well, connect the dots when we were kids, right? So imagine the night sky stars are all dots. You can connect them. And when you do them, you can actually identify the various constellations in the night sky. And I've made this beautiful puzzle, which I'll share with all of you through a link at the end, where you can actually have more details like this for different constellations, where I'll plot here at the bottom position of the objects in the night sky and the orientation that you need to hold this puzzle to identify the constellation. So with this, you can actually learn how to spot constellations. And then there are sky maps. You can download many sky maps online. Find the one relevant to your location. I have made these also. I will share this. These are specifically to Indian time, so you'll find it better. The Indian latitude, more specifically, and you'll find some history and regional names written in here. So you can download this. More advanced for BSc or MSc students and astronomy clubs, you can do such activities like calculating the size and mass of stars. In fact, you can find the radius of Betelgeuse. And if you calculate the volume of Betelgeuse and the volume of our sun, you'll realize that you can fit about 10 lakh Betelgeuse, 10 lakh suns inside the star Betelgeuse. You see, the sun is a very, very, very small star here. My laser pointer is bigger than the sun in this image. And Betelgeuse is a huge, huge, huge star. So you can calculate the volume of different stars and identify how many suns can sit inside. Or here are more complex problems, like you can actually calculate the collision time of stars within a galaxy and identify will it really happen. And you can find out if two galaxies can collide, how often can that happen? They say that when two galaxies collide, the stars are so far apart that no stars will collide with each other. That is something very fascinating. You can find animations online where galaxies collide and they're thrown away here and there, but none of the stars collide. So you can actually calculate these things. You can calculate the lifetime of a star based on its temperature and so many other parameters. In fact, there's a very good book where these calculations are mentioned. It's called Astrophysics for Physicists. Sorry, this should be physicists, written by Arnab Rai Chaudhary, a very prominent solar physicist in India. And one of the very good activities that you can do with public members of the public and school children are citizen science projects. You know that Juno, the satellite sent to observe Jupiter, takes so many photos, and all of these photos are public. And if you go to their website and download these images, you'll find different images like this for various colors. So for those of you who are interested in editing photos, graphic designing, who understand color maps or channels or color channels, or you want to learn also, that's fine. You'll find several tutorials on YouTube. You'll realize you can download these images and colorize them yourselves, and you'll get some beautiful images like this. This is something I have made myself. This is a view of Jupiter we will never see from Earth. But look at Jupiter, how colorful it is. I have not exaggerated anything here. It is basically what the satellite observed. But I put it together so that the world can see. You can find beautiful images from different angles and color them. And you'll realize Jupiter is actually very, very, very colorful. And the other very important, very prominent citizen science project that happens is a international astronomical search collaboration where NASA is a partner, and with the Pan-STARRS telescope, people actually find asteroids that are not known to us. And these details that you submit to them is actually submitted to NASA IAU's Minor Planet Center. So what you essentially do is you sign up as a group of 4 or 5 people on their website, and they will allot you a certain month. You can find online tutorials of how to do this. On YouTube, there's a big series explaining everything in detail. And if you do this, every month you'll get a few set of images which you put through a software which is explained in that tutorial video. It's going to be lengthy if I explain this. I'll skip it, but you can find this online, or maybe I can share it on the WhatsApp group or something. So you process these images. There's a process called blinking, where each of these images is shown very quickly in sequence. And when you do that, you'll realize some of these dots are not really stars; they are moving. And then you quickly label them. You identify these objects. You mark them. You label them. You there's a process to follow, and you submit it to them. And when you do it, they will submit it to IAU's Minor Planet Center, and they will track this object for a long time. And there has been instances where once the planet is confirmed, sorry, once the asteroid is confirmed, you will get a credit that you have identified this. And there are rare cases, but still possible, that once NASA confirms after 5 years the proper orbit of this asteroid, may allow you to name this asteroid as well. So it's a great chance. And at the end of it, you'll get a certificate. So you get a certificate for every campaign. So essentially, if you do this every month, you'll get one every month, one certificate every month. So you'll have your name, your group name here, and all of these things. And this is something that everyone should do because people around the world are doing this. So what stops us? It's very easy. You see, these are all elementary kids. They can manage a computer today. They can operate a software today. Then all of us should. Several people across the globe do this. And this is not just limited to youngsters, adults also do this. My college people also did this. So why not your institution? And some of these institutions have been famous for doing this. School students who have discovered asteroids, a bunch of them, actually get some credit. So we should all do such activities in our astronomy club. With that, I have finished my limited number of slides. I have listed 3 websites here. These are very important websites, especially the first one. It has everything you need to know about to track things, to organize things, and all that. Sky and Telescope is more of a magazine website, so they have a lot of articles and posts written on it. The Sky Live is also a beautiful website where you can look at many facts about the sun and the moon. And I would also put together all of my resources, the crossword I showed you, the puzzles. And in fact, I'm really sorry if I think I can share the image here. I'll quickly try to stop this PPT and share an image. Let me just find it. I would like to share actually some of my posters which I've done. Let me just quickly find it. Give me just a few seconds. I have it here. So these posters, you can find it once my link that I've put there, my website link I've put there. Just a second. Oh yeah, fine. So let me share some of the resources I've created. Okay. I'm switching presentations. So bear with me for a while. Yeah, this presentation. This is another presentation I made for some other time, but uh, these are the things I've created. So if you go to the link that I've created, I hope the PPT is visible. Yeah, okay. So on the link, the atulbadis.com, I'll put that slide back again. So atulbadis.com/astronomy, my website, I'll create a page. I am still to do it, so please do not visit it today. You'll not find anything. But if you go to that page, I'll make sure you find all the posters I've designed. So these posters I have, wait, let me just show you. Yeah, posters like this, which tells you certain things about the night sky. In fact, these are very high resolution posters. You can print them in A3, A2 sizes and paste it on your astronomy clubs, interiors, and so on and so forth. So you have these posters about the equinox, the festivals we have, eclipses, the meteor showers, and so on and so forth. This is something about the social media. So yeah, these posters, these sky maps, all of these things will be available on the website I have created. So uh, if I'm able to finish it by few months, I will try my best to. But if that happens, you can actually visit my website here on this link, the first link here, and you'll be able to find all of the resources that I have created, especially the posters that can be utilized for each of the astronomy club that pops up after this talk, and also the existing astronomy clubs as well. And if you want updates about astronomy events, this is the site you need to look at. So if you do this, you'll be able to run an astronomy club efficiently for all age groups very nicely. And if you have any questions to ask me at a later point, this is my email address, so you can also um, use it and write to me, and I can reply back. So that's about it. That's what I plan to tell you guys.
All right. So I think Atul,
Yeah.
most of the things were quite clear to us. So in fact, I also have an astronomy club in my college, and I have been trying to run it, but mostly it has been like uh, organizing talks and those things only. We also have a telescope in the college, but it's not functioning. Hopefully, we'll try to get it up soon. And as you have, I think today's talk was really wonderful for me because it really helped me to understand how to really go about things so that things it can be made really interesting basically. So that way, I think it will be helpful for our students also if they want to do any outreach activities and such things with the school students basically.
Hmm.
So thank you, Atul. So let me now. This is just a formality. So let me present my vote of thanks to you. So I think the delivery was absolutely perfect. So whatever points you had put forward, those were really interesting. And I personally have been trying to run an astronomy club, and I have found it extremely difficult. But after today's lecture, I'll definitely try to do something better. And I thoroughly enjoyed every part of the presentation. Thank you, Atul, for all the hard work that you had put for the talk. I'm sure the students will benefit immensely from the talk. And at the same time, I would also like to thank the students for taking out the time to attend the webinar. So, with that, I would like to conclude, and also I would like to convey my best wishes so that you can continue your wonderful work. So, any last comments from you, Atul?
Uh, yeah. So all the best for anyone who's gonna start an astronomy club or revamp it.
Yeah,
Talks are essential, but these activities are what teach us the basic things. So
correct, correct.
go ahead with that.
Yeah. And Atul, are you planning to visit this part of the country anytime because of
I
some
would love to.
seminars?
I would
Okay.
love
So,
to, but
so
let
let
me
us
see the
know.
opportunity. Sure.
Yeah, because there are a lot of events relating to astronomy going on. So maybe if
Mhm.
you come sometime, let us know so that we can also arrange a kind of a small talk in the department itself. So
Sure.
that would really help us, Atul.
Sure. Sure.
So thank you once
Yeah.
again. So let's
Thank you.
hope to meet again in the future.
Sure.
Thank you. Thank you. Bye.